Hello friends, welcome to online lecture series. This is the 15th lecture of your unit number 1, that is wave mechanics. Okay, so in our previous lecture we derived Schrodinger equation for hydrogen atom. It means Schrodinger equation in polar coordinates. In this lecture we will discuss about separation of variable. There are three variables. First one is r, second one is theta, and last one is phi. Okay, so in this lecture I will separate all the three variables of polar coordinates. Okay, so first, in previous lecture, what is the last equation of Schrodinger equation? Okay, the last equation 1 upon r square del by del r into r square del psi upon del r plus 1 upon r square sin theta into del by del theta into bracket sin theta d psi upon d theta plus 1 upon r square sin square theta del square psi upon del phi square plus 8 pi square mu upon a square e plus e square upon r into psi is equal to 0. Okay, so this is the last equation in our previous lecture number 14. Okay, so there are three variables in this equation. First one is with respect to r, second one is with respect to theta, and last one is with respect to phi. Okay, and this is the Schrodinger equation for hydrogen atom in polar coordinates. Okay, so here the value of psi xyz means Cartesian coordinate. The value of psi is the xyz. Now it will become in polar coordinate, therefore psi r theta phi. Here the value r theta phi indicates coordinates of in polar. Okay, so the psi is the product of three different wave functions. First one with variable r of r, second one theta of theta, and last one phi of phi. Okay, and where the value of r of r, what do you mean by r of r? R of r is the function of variable r only. R of r is a function of variable r. Theta of theta is a function with variable theta, and phi of phi is function with variable with respect to variable phi. Okay, so in our previous lecture we draw the figure of hydrogen atom, then after we apply four different functions, sin theta, cos theta, and sin phi, cos phi, and we get the value of Cartesian coordinate into polar coordinate. Okay, and finally we simplify Cartesian coordinate into polar coordinate by using partial derivative. Okay, so here in this case this equation is we derived in our previous lecture number 14. Now in this lecture I want to separate this variable. First one is r, second one is theta, and last one is phi. Okay, so here the value of psi is equal to, here in this case same as particle in three-dimensional box, three coordinates are given in particle in three-dimensional xyz, but here in this case in polar coordinate, therefore r, theta, and phi. Okay, so psi is not an individual function. Psi is not an individual function. Here is psi is a function of three different variables. It means variable r, second variable is variable theta, and last variable is phi. Okay, so psi is a product of three different variables in polar coordinates, r, theta, phi, and in three-dimensional box variable is fx, fy, and fz. Okay, so same as in polar three-dimensional box, psi is a function of fx into fy into fz, but in this case psi is the product of three different wave functions, r, theta, and phi. Okay, so put the value of psi in equation number 2. Here psi is equal to r theta, r of r, theta of theta, and phi of phi. Okay, psi is equal to r theta phi. Here also psi is equal to r theta phi. Here also psi is equal to r theta phi, and last one is psi is equal to r theta and phi. Okay, so put the value of psi. Psi is a product of different three wave functions, that is r, theta, and phi. Okay, so 1 upon r square del by del r square, del by del r square, del by del r. Now the value of psi is equal to r, theta, and phi. Therefore r, theta, and phi plus 1 upon r square sin theta, 1 upon r square sin theta, del by del theta, into bracket sin theta del by del theta, sin theta del by del theta. Now the value of sin is equal to r of r into theta of theta into phi of phi. Okay, so the value of sin is equal to r of r, theta of theta and phi of phi plus 1 upon r square sin theta del square upon del phi square, 1 upon r square sin theta del square upon del phi square, and the value of sin is equal to, here sin is equal to r of r, theta of theta and phi of phi. Okay, so r of r, theta of theta and phi of phi plus 8 pi square mu upon s square, 8 pi square mu upon s square, e plus e square upon r, e plus e square upon r. Now what is the value of sin? Sin is equal to product of three different wave function in Cartesian coordinate f of x, f of y and f of z, but in polar coordinates r of r, theta of theta and phi of phi. Okay, so the value of sin is equal to r of r, theta of theta and phi of phi. This is the equation number 3. Okay, but we can see that here this differentiation with respect to r only, this first term differentiation with respect to r only, it means at that time the variable theta of theta and phi of phi will become constant for r. It means theta of theta and phi of phi will get outside of the differentiation. Okay, so here variable is r, so these two variables are constant in this case. These two variables are constant in first term, same as second term, the variable is d by d theta. Okay, so these term and these terms are constant for second term because the variable is differentiation with respect to theta, and last one differentiation with respect to phi, differentiation with respect to phi. It means here in this case these two functions are constant, so it will goes outside of the differentiation. Okay, so first here in this case theta of theta and phi of phi will goes outside the differentiation. It means theta of theta, phi of phi upon r square into bracket del by del r square into bracket del by del r and del by del r of r. It means in first term only one variable is present with respect to r, that is r of r. Okay, so in second case, second step term theta of theta, and in last term phi of phi. Okay, here in this case differentiation with respect to variable phi, so this term will become variable in this case and this term will become constant. Okay, so it goes outside the differentiation. Okay, so plus 1 upon r square sin theta and plus 1 upon r square sin theta. It means here in this case r of r and phi of phi both are constant, so it will goes outside the differentiation. It means r of r and phi of phi upon r square sin theta into bracket del by del theta sin theta into bracket del by del theta sin theta into del by del theta of variable theta of theta. Okay, and in last term these two terms are constants, therefore r of r into theta of theta upon r square sin theta, r of r theta of theta upon r square sin theta into del square phi upon del phi square, plus here in this case there are no variables, this is the constant term. Okay, this is the whole term is constant. In first term variable is r, in second term variable is theta, and in third term variable is phi, and in last equation 8 pi square mu upon s square, 8 pi square mu upon s square e plus small e square by r of r, theta of theta and phi of phi. This last term is constant. Okay, so this is the equation number 4. Now I multiply equation number 4 with r square sin theta upon r of r, theta of theta and phi of phi. Okay, so here in this case first these two variables are removed, these two variables are cancelled. It means here these two variables are is in numerator term, and if I multiply this term then these three variables are in denominator term. It means theta of theta and phi of phi cancel, theta of theta and phi of phi cancel, so it will remaining term is here r square and r square both are cancelled, so remaining term is sin square theta upon r of r, sin square theta upon r of r into bracket del by del r del r square into del by del r of r. So it will remain as it is. Okay, so if I multiply this term with equation number 4, first this is first term, this is the second term, this is the third term, and this one is the last term. Okay, so here r square both are cancelled, these two phi of phi and theta of theta and phi of phi both are cancelled. So remaining term is only sin square theta upon r of r plus this term remain as it is, plus here in this case r of r and phi of phi both are cancel out. It means r of phi and phi of phi both are cancel out, and r square cancel out. Sin theta upon sin square theta divided by sin theta. So at that time one side theta is also cancelled. Okay, so remaining term is here r square cancel. One term sin theta cancel. So remaining term sin theta upon theta of theta. Okay, so sin theta upon theta of theta into bracket this term remain as it is. Okay, theta of theta sin theta del by del theta theta of theta plus here in last term r of r and theta both are cancel out, and r square sin theta both are cancel out. So remaining term is 1 upon phi. So remaining term is 1 upon phi of phi. Okay, so 1 upon phi of phi into del square phi upon del phi square plus here in this case in last term this r theta and phi all the variables are cancel out, and remaining term is only r square sin theta. So 8 pi square mu upon a square e plus e square upon r, and remaining term is only r square sin theta with in multiplication. It means r square sin theta. So this is the equation number 5. Okay, so first equation number 2 we derived this equation in our previous lecture number 14. First of all, this equation contains 3 variables. First one is r, second one is theta, and last one is phi. Okay, now for separate out of these 3 variables we need some basic mathematical calculations. Okay, so here sin is not a variable, sin is not a function of one variable, sin is the function of product of 3 different variables. There are r, theta and phi. So put the value of sin in equation number 2. Here put the value of sin at this position, and this. Okay, so put the value of r sin. Okay, here and here. Okay, at 4 different places put the value of sin. Then after this term, first term contain only one variable, that is r. So at that time these 2 variables are constant, so it goes outside of the differentiation. Okay, so here in this case variable is theta, so these 2 variables are constant for second term, and last term contain variable phi, so these 2 variables are constant for third term, and last term contain constant, all of these constant. Okay, 3 variable, and last term is not a that is not a differentiation calculation. Okay, so we common out these 2 variables in first term, second term these 2 variables, and in last term these 2 variables. Okay, so equation 3 will becomes this type equation, that is equation number 4. Okay, so now multiply equation 4 with r square sin square theta. It means at that time this theta of theta and phi of phi cancel, r square also cancel. So remaining term is sin square theta into r of r, sin square theta upon r of r into del by this term remain as it is, del by del r square del by r of r. Okay, and second term will become here r of r and phi of phi both are cancelled, so remaining only theta of theta and r square also cancel, sin theta cancel at one times. It means remaining term is sin theta upon theta of theta, sin theta upon theta of theta. So here this term remain as it is, theta of theta sin theta del by del theta theta. Okay, and in last term, it means third term, here r of r and phi of r cancel, r of r and phi of phi cancel, also r square sin theta cancel out. So remaining term is only 1 upon phi of phi. It means 1 upon phi of phi del square phi, this term remain as it is, del square phi upon del phi square, del square phi upon del phi square. And in last term, all the three variables are cancelled out. Okay, so remaining term is r square sin theta within multiplication. Here 8 pi square mu upon a square, r square sin theta into e upon e square upon r into bracket e plus e square upon r is equal to 0. This is the equation number 5. Okay, so in equation number 5, that is first term, that is the second term, this is the third, and this one is the fourth term. Okay, so if third term, it means 1 upon phi of phi into del square phi upon del phi square. If this term goes right hand side, then it will become minus, because this term contain only one variable, that is phi. Okay, so the third term, if this term is goes right hand side, then it will become minus. It means sin square theta upon r of r del by del r into r square del of r over r into del by del r plus sin theta phi of phi theta of theta into del by del theta sin theta into del by del theta upon del theta, and this term will goes right hand side. Okay, so remaining is plus 8 pi square mu upon r square sin theta into bracket e plus e square upon r is equal to, this term will become minus. Okay, so minus 1 upon phi of phi del square phi upon del phi square. Okay, so this equation is known as phi equation, because it contains only one variable, that is phi. Okay, so therefore minus 1 upon phi of phi into del square phi upon del phi square is equal to what? Suppose we assume that term is equal to m square. Okay, so this is the phi equation, and one variable is separate out. It means phi variable is separate out in Schrodinger equation of polar coordinates. Okay, and now I put the value minus 1 upon phi of phi into del square phi upon del phi square is equal to m square. Okay, so the right hand side will become m square. Okay, so sin square theta r of r into del by del r square del r upon del r plus sin theta del by del theta sin theta del theta by del theta, and 8 pi square mu upon a square r square sin square theta, and this term will become m square. Okay, so this is the equation number 7. Now divide equation 7 with sin square theta. At that time, this sin square theta and this sin square theta both are cancelled out, so remaining 1 upon r of r into del by del r, and this term remain as it is. Okay, so here in this case, second term, sin theta cancel out one time, sin theta into sin square theta, sin theta cancel out. At that time will remaining 1 upon sin theta into theta of theta, this term remain as it is. Okay, and in third step, this sin square theta and sin square theta both are cancel out. Okay, so remaining term is 8 pi square mu upon a square r square into bracket e plus e square upon r, and here m square divided by sin square theta. This is the equation number 8. Okay, in equation number 5, if third term goes right hand side, then it will become minus. This is the phi equation. We assume the value of minus 1 upon phi del square phi upon del phi square is equal to m square. Okay, so it will become equation number 7. Now divide equation 7 with sin square theta, because first term contain both two variable. First one is theta and second one is r. If I want to separate out r and theta, then I want to divide all the equation by sin square theta. Okay, so first term contain only one variable, that is r. This term contain only one variable, that is r. This term contain only one variable, that is theta. Okay, and this is the constant term. Okay, so here in this case, if I want to separate out theta and r in first term, at that time divide equation 7 with sin square theta. Therefore the value of sin square theta both are cancel out in first term. Here in second term, sin theta cancel out at one time, so remaining sin theta in denominator. Okay, in third term, this sin square theta and this sin square theta cancel out. Okay, so here right hand side also m square upon sin square theta. So this is the equation number 8. Okay, now in equation number 8, if second term goes right hand side, then it will become minus. Okay, here the first term, this is the second term, and this is the third term. If second term goes right hand side, then it will become minus. Okay, so therefore 1 upon r of r into del by del r into r square del r upon del r plus 8 pi square mu upon l square e plus e square upon r. It means first and third term. This is the first plus third term. If second term goes right hand side, then it will become minus. It means at right hand side remaining term is m square upon sin square theta minus m square upon sin square theta minus 1 upon sin theta into theta del by del theta sin theta del by del theta upon del theta. Okay, so here m square sin square theta minus this is the theta term. Okay, so this is the equation number 9. Okay, so in equation number 9 we can see that at right hand side only one variable is present, that is theta. In whole term only one variable is present, that is theta. Okay, so equation 1, suppose I assume the value of right hand side is equal to beta. The value of right hand side is equal to beta. Okay, so this is the theta equation. M square sin theta sin square theta minus 1 upon sin theta into theta into del by del theta sin theta into del theta upon del theta is equal to beta. Okay, so I put the value of right hand side is equal to beta in equation number 9. Okay, 1 upon r of r into del by del r square into del r upon del r plus 8 pi square mu upon a square e plus e square upon r is equal to the value of right hand side. It means whole term will become beta. Okay, so this is the theta equation. We separate out second variable, that is theta. Okay, so this is the equation number 10. Okay, so now multiply equation number 10 with r of r and r square. At that time this r of r both are cancel out. At that time remaining term is 1 upon r square del by del r into r square upon del r upon del r plus 8 pi square mu upon 8 pi square mu. It means here in this case no any term r cancel out, so it is remaining r of r here and r square here. It means 8 pi square mu upon a square upon r square and e plus e square upon r into r of r is equal to here right hand side beta into r of r divided by r square. Okay, so this is the equation number 11, and this is equation number 11 is called r equation, or it is also known as radial equation. Okay, so this is the third variable. Okay, so in our Schrodinger equation for hydrogen atom we separate out all the three variables. Okay, so this is the equation of phi. This is the phi equation. It contains only one variable, that is phi. And this is the theta equation. It contains only one variable, that is theta. And this is the r equation or radial equation. It contains only one variable, that is r. Okay, so we separate out all the three variables in Schrodinger equation. This is the not easy theory. This theory contains many more mathematical calculation. Okay, so this is not a simple theory. Okay, so this is the equation number 11 and I completed all the theoretical parts of wave mechanics. So thank you for watching this video. In next lecture I will start some numericals which are based on wave mechanics. Okay.